Hello, my name is Noah Abji, and today we're going to learn how to graph on the first quadrant of a coordinate plane. So what exactly is a coordinate plane and why do we use it? A coordinate plane is kind of similar to a number line, except instead of only going right to left, it also goes up and down. And in that way, we can represent the relationship between two variables. So this is what a coordinate plane looks like. You have an up and down and a left and right. And you can kind of think of the left, right, and up, down arrows here as different number lines, except instead of only going left and right, they're going in two different directions. So to understand exactly how the coordinate plane works, let's actually revisit our example of the number line. So here I have a number line starting at 0 and going out to 1, then 2, and then 3, 4, 5, and so on. So in this number line, if I were to tell you to plot the point 3, you would draw a circle right here. And if I were to tell you to plot the point 1, you would draw a circle right here. Now that's pretty simple because we only have one spot that can be 3 and one spot that can be 1. But if I told you to plot the point 3 on a coordinate plane, it would be a lot more difficult because you wouldn't exactly know where 3 would be because there's a 3 here and there's a 3 here. But if I only wanted you to plot one point, then you wouldn't know where to plot it because it could be either of those two values. So because a coordinate plane has two different dimensions, it doesn't just go left and right, it also goes up and down. We have different names for the different values. If you wanted to plot a point going left and right, that's called an x value. And if you want to plot a point going up and down, that's called a y value. So here's how coordinates work on a coordinate plane. It's not just one number, but it's two numbers, representing your x and y value. So the first value is your x, and the second value is your y. So if I were to tell you to plot the point 3, 8 on this coordinate plane, remember, this 3 represents your x value. Now, since we know it's our x value, that means it's going to be on this axis, the one going left to right. 3 on this axis is right here. So we can go 3 out for our first step of plotting this point. The second part of this point is the number 8, and this represents our y value. Our y value is on the axis that goes up and down. So it's telling us that this point is going to be 8 up, which is right here on the axis. So now if we combine those two values, we go 3 out, 8 up, we get this point here as our point that represents the number 3, 8. All right, let's do some practice questions. If you'd like to give it a try to plot these points, I'll give you a few seconds to pause the video and then I'll explain the answers. So here are the points for the answers. I accidentally skipped back to the last slide. So point A is right here on the graph, and point B is right here on the graph, representing 1, 6, and 7, 3. So if we were to plot these points, we'd have to remember these first values in our points, the 1 and the 7, represent our x values. X values. So these are going to represent how far out we go because they're representing the right and left of the point. So for point A, our x value is 1. Now, since our x value is 1, that means along the x-axis, which is this bottom axis going left and right, we go one slot out. So 1 out is right here. Now, our second value in both of these coordinates represents our y value. Remember, our y value tells us how far up and down we go. So for our first point, we go 6 up because our y value is 6. So now if we combine those two, going 1 out for our x and 6 up for our y gets us this point here at 1, 6, which is point A. For point B, our x value is 7, which means we're going to go out 7 different slots. 1, 2, 3, 4, 5, 6, 7. And we end up here on our x-axis. Now, we also need to go 3 up because our y value is 3. So going 3 up would be 1, 2, 3. And I'll draw the arrows, 1, 2, 3. We go 3 units, And now we're here at point B. So point B is here on our graph. All right, so next we need to talk about how to graph simple equations. We know how to graph points on coordinate planes. We know that we can go a certain amount up, out and a certain amount up, which represents our x and y values. But we can also make x and y related. So here's an example of an equation that we could graph. And this might seem confusing at first, but bear with me, I promise I'll explain it. This equation is y equals x. So here's how we're going to do this. We're going to make a table. Here's our table representing our x and our y values. So when we graph equations, we get to choose any point that we want our x to be. So let's say we wanted x to be 2. So if x is 2, and we know that y equals x, since x is 2, that means y equals 2. So when our x value is 2, our y value is also 2. So let's plot that point on our graph. X is 2, so we go 2 out, because x represents how far right or left we may be. And our y value is also 2, so we go 2 up, because y represents how far up or down we may be. So going 2 out and 2 up gives us this point right here. Let's do another point. Let's say we wanted our x value to be 6. So in our table, we're going to write 6 for our x value. Now, since y is equal to x, and x is 6, then y would have to be equal to 6 in this case. So for our y value in this table, we can write 6. Now let's plot this point as well. When x is 6, y is also equal to 6. So if we go 6 out, then this is our x. And if we go 6 up, then this is the final point for 6, 6. When x is 6, this is what y is equal to. Now, if we keep doing this for different points, such as when x is 4, we will get y is 4 and plot it on the graph, 4 out, 4 up. Eventually, we'll notice that these points can be connected. If x was 4.5, y would be 4.5. If x was 2 1/3, y would be 2 1/3. And if x was 0, y would be 0. And we could do this for an infinite amount of points and plot an infinite amount of points on the graph. So instead of plotting all these points, what we do is we plot a few of them and draw a line through them, just like this. And theoretically, this goes on forever. If x was 9, y would also be 9, which would be about here on this graph. And if x were 10, y would also be 10. And we would have points in between as well. So what we do at the end of a line is we draw an arrow to show that it will go on forever. So we can plot our points using an equation if we just choose values for x and draw a line connecting those points. Let's look at another example. Y equals 2x. So a good way to start is always to draw a table. So this will be our x value and our y value. So remember, we get to choose values for x. So let's say when our x value is 1, then our y value would be equal to, since y is equal to 2x, 2 times 1, because x is 1. 2 times 1 is equal to 2. So when our x is 1, our y is 2. It's twice of the x. If our x is 0, then y is 2 times 0. Y equals 2 times 0, and that is just 0. So y is 0 then. And if our x value was, let's say, 8, actually, instead of 8, we'll do 4. Because when x is 4, y is 8. Because y equals 2 times 4, and that's 8. I didn't say x was 8 because that would go off this graph. So now we can plot some of these points. When x is 1, so if we go 1 out, y is 2, so we can go 2 up. When x is 0, 0 out, y is also 0. So here's a point right here at what we call the origin, 0, 0. And when x is 4, if we go 4 out, y is 8. So we can go 8 up. And now we have 3 points that we can connect in a line. So if we draw a line between these 3 points, starting at our bottommost one and connecting through all of them, we end up with this line representing y equals 2x. Now this may be a confusing concept, so I'm actually going to give two more examples that we can graph. The next one is y equals x plus 5. So let's make another table for x and y values. So again, we can just choose values for x. Let's start with 0. When x is 0, y equals x plus 5. So y equals 0 plus 5, and y is just equal to 5. So we put 5 here. When x is equal to 1, y is equal to x plus 5, which is 1 plus 5, and 1 plus 5 is 6. When x is 2, y is equal to 2 plus 5, because 2 is x, and that gets us to 7. And we'll do one more point. When x is 3, we get y equals 3 plus 5, and that's 8. So now if we plot a few of these points on our coordinate plane, we get 0 out, 5 up. That's our first point. Then 1 out for our x. Then we get 6 for y. When we put 2 for x, which is 2 out, we go 7 up, which gets us 7 for y. And one more point, 3 out, 8 up. And we can connect a line between those ones to get this as our line for this graph. So this line represents the equation y equals x plus 5. And the final example combines all of these ideas where we multiply and we add. Y equals 3x plus 4. So let's make one more table and start with the point 0 for x. 0 is always a good place to start. So when x is 0, y is going to be equal to 3 times x, which is 3 times 0 plus 4. 3 times 0 is 0, and y is just equal to 4. When x is 1, y is going to be equal to 3 times x, which is 3 times 1 plus 4. So y equals 7, because 3 times 1 is 3, and plus 4 is 7. And one more point is when x is 2, y equals 3 times x, or 3 times 2, plus 4. So y is going to be equal to 6 plus 4, because 3 times 2 is 6, plus 4 is 10. So y is equal to 10. So now that we have 3 points, we can put them on our graph. 0 out for our x gives us a y value of 4. When we're 1 out, we get a y value of 7. And when we're 2 out, we get a y value of 10. And just, we can estimate where 10 is on this graph. 10 is probably around here. Now if we connect these 3 points, we get our line representing this equation. So this line, and remember we put an arrow because it extends on forever, represents the equation y equals 3x plus 4. So now let's look at just a practice question that you can try on your own. So here's the practice question. Y equals 3 plus 2x, and you can try and graph it if you'd like. I'll give you a few seconds to pause the video and they'll explain the answer. All right, so this is the line that represents y equals 3 plus 2x. So let's actually plot some points, make a table, and graph it so I can prove it. So you should always make a table when graphing. So now let's put our x and y on this table and figure out how x and y are related. So remember, we always get to choose values for our x because we're doing different things to x to figure out what y is going to be. So when x is 0, let's figure out what y is. Well, since y equals 3 plus 2 times x, or 2 x's, it's 3 plus 2 times 0. 3 plus 2 times 0 is just 3 plus 0, and 3 plus 0 is 3. So when x is 0, y is 3. All right, next, when x is 1, y is going to be equal to 5, because y equals 3 plus 2 times 1. 2 times 1 is 2, so 3 plus 2 is going to be equal to 5. So y is 5 when x is 1. And let's do one more point that we can put on our graph. When x is 2, y is going to be equal to 7 because y equals 3 plus 2 times x. X is 2, so it's y equals 3 plus 2 times 2. 2 times 2 is 4, and then if we add 3, we get 7. So y is equal to 7 when x is equal to 2. So we can put that on our table as well. Now we have a few different coordinates that we can graph. When x is 0, y is 3. So if we go 0 out and 3 up, we get this point right here. When x is 1, y is equal to 5. So we can go 1 out because x is on our horizontal axis, and 5 up because y represents up and down, and we get this point right here. And finally, when x is 2, y is 7. So if we go 2 out for our x, y is 7, so we go 7 up, and we get this point right here. So now if we connect those 3 points, we're going to end up with this line, which is exactly the one that's on the graph. And this represents y equals 3 plus 2x. That's all, and thank you for watching.